For part B, our sequence is n cubed divided by n to the fourth power minus 7. Now, just like our previous example, I am going to use both methods. So I'll use the first method where we divide throughout by the highest power of n. Now in this case, the highest power of n is 4. So I'm going to divide throughout by n to the fourth power. So that will give me n cubed divided by n to the fourth power divided by n to the fourth divided by n to the fourth minus 7 over n to the fourth. That gives me the limit as n tends to infinity of 1 over n divided by 1 minus 7 over n to the fourth power. Now just draw a line here and come up. So I'm going to get, when I substitute in, that this is equal to, so I can state this is equal to by using a little deduction. 1 divided by n, that's going to tend to 0 as n tends to infinity. So my numerator is 0. And let's see what my denominator. Well, 7 over n to the 4, that's going to tend to 0. Because, for the same reason, as n gets really, really large, this fraction is going to get smaller and smaller and smaller. So it's going to tend to 0. So my denominator is 1. So my limit is actually 0. And we can then conclude that un is convergent. So un is convergent. And what does it converge to? It converges to 0. Now let's look at it using L'Hopital's rule. We would have the limit as n tends to infinity of some, going to differentiate this. We're going to get 3n squared divided by 4n cubed. Now clearly substituting n as infinity is going to give us infinity divided by infinity still. So what we do, we differentiate again. We now get 6n divided by 12n squared. We still have the case of infinity divided by infinity. So we differentiate again. That will give us 6 divided by 24n, which we can do a little simplification there to give us 1 over 4n. Now, as we substitute in n tends to infinity, and we apply this principle, our denominator is going to get really, 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 really large, which means that our fraction becomes smaller and smaller and smaller, i.e. it tends to 0. So you see, we still got the same result. However, we had to do a few iterations of our derivatives. So you can decide which method you prefer. We can either use this method or we can use L'Hopital's method. It's up to you. But that's it for this lesson. So thank you for watching.